In this video, we'll first start by studying a drawing, and from that drawing we'll construct a 3D model. Let's study the drawing and develop a strategy to prepare our 3D model. The first point we notice is that there is a base view on the left and a midsection view on the right. Let's take a deeper look at the drawing and develop some ideas. We can clearly see that the diameter of the cylindrical portion, both from the top and the bottom side, is 16 mm. Therefore, we need to create a single cylinder of diameter 60 mm and a height of 28 mm. The next most important feature is this triangular pad with a thickness of 12 mm. And in addition to this, we also need the placement of these holes. We can clearly see on the base view that it lies on a circle of diameter 86 mm. Since nothing else is specified about these holes, we can assume that these are symmetrically aligned at 120 degrees each. The corner radii of this pad are 12 mm and they have the same center as the dia 11 holes. Additionally, there's one more feature about these holes, which is the counter bore, as we can see here. The counter bore has a diameter of 16.5 mm and a depth of 2 mm. From the basic understanding of this drawing, I can already visualize the steps that we need to follow. We can start by drawing a sketch of the triangular periphery, followed by the circles corresponding to the inner and the outer diameter of the cylindrical feature. Finally, we can extrude the two sketches separately to make the final shape. Now, let's move on to the next section, which is to prepare the 3D. As you can see, my NX is already open. And let's straight up start with making the sketch. Choose the XY plane here. Okay, so the first point that we can already see here is that we need to have this R12 radius circle. This is oriented at 120. The centers of these three R12 circles are oriented at 120 degrees to each other, and all of these lie on a circle of diameter 86 mm. So let's start with making this diameter 86 circle. So the diameter is 86. Now first we basically need to make a point on this, which is oriented at 60 degrees. Let's make a random point on this surface, and then later on we can need to stop this. Later on we can actually make some dimensions. This is being auto dimension there. Let's stop continuous auto dimension and delete this dimension here. Okay, since it is an angular dimension, what we can do actually is we can actually draw a line which should make it easier for us. So we can simply delete this point instead. That would be an easier strategy here. So this angle should be 60. Now we can actually create three such lines by using the pattern feature. Let this specify the center point as this. We can do count and span. We need 3 of these at one, so 360. 60 as the span. Apply. Let's now draw these 3 R12 circles and the intersection points. So I have selected this the intersection here, and now I need to basically make this 3 outer circles. In fact, I could simply delete this and simply make this as a pattern feature. So let's put a radius on this. In this case, the radius is 12, so we can see the diameter. Either we can simply change it to radial, or we could stick to diameter and basically let's do this as radial, just so it is same as this, avoid confusion. Then we can change the radius to 12 as is mentioned in the drawing. Let's save it, close, and OK. Now we need to basically have 3 of these circles. So let's go here and choose the pattern curve. Equal to center point is this, and since we had already done this before, so it will show up as the same. We need 3 and around the span of 360 degree. Set OK. Now as you can see that the edges of this triangular portion are tangent to these corners. So let's do that. Okay, we need to deselect this center point selection, and now we can draw these lines. We can trim the inner sides of this now to make just the outer shape. So let's choose quick trim. So we are done here. Since this circle and this particular line are not a part of this sketch, so we can actually convert them into reference dimension. So let's start doing that. We can right click this and click on convert to reference, and similarly we can do the same for this one. Now convert to reference. Now let's draw this protruded portion here, which has a height of 38.5 from the center point. So let's simply make it line here, and let's dimension this. No, 38.5. We also know that the width is 28, so let's draw one half side of this, then we can basically mirror it out. Let's put the linear dimension as 28/2. Close it. Then we additionally have this groove shape. So since the width is 5, we can simply draw a vertical line here, and the dimension can be taken as half of 5, so that would be 2.5. Again, the bottom face height is 6, and it is not the same as this line, so let's also draw one more line here, and then put a linear dimension of on this line as 6 mm. So let's go ahead and trim all the excess curves now. We can again go and select the quick trim feature. I'll zoom in a little bit so that we can see everything more clearly. I think we actually trimmed even the bottom line. Let's make that again. And now we can trim it. Of course, this width would be 2.5 mm, which already has been set up, but this time we will set some boundary curve. Last time what happened is that there was no obvious intersecting line that was cutting here, so when we trimmed it, the whole thing got trimmed out. So let's select the boundary curve as this axis and the curve this. Now we can already see that this is perfectly done. Let's again put a dimension on this. It was lost. This would be 6 mm. It is already there. Let us mirror this curve and then we can do the trimming. And select the mirror curve. So first we need to select curves that we need to mirror. That would be these curves. And the center line is this axis. And hit OK. Now we can trim every wherever we can see an axis line. And go to quick trim. Here we don't need to specifically specify the boundary curve. It's automatically taking that. Now as we can already see that most of this area is already done. We can maybe also go ahead and make these diameter 11 holes here and the diameter 16 as well. We could also choose to do it by making just a point and doing a counterbore hole. So let's do that instead of making it as a part of sketch. Now we can also in this sketch itself make the central uh, cylindrical part. Let's make that. So this in this case we have a cylindrical portion of diameter 60 mm. Let's go ahead and put a diameter on that. So it is taking is 55, so let's change it to 60. On the central cavity portion I would rather choose to make as a hole because we can automatically select the center point of this hole. So let's finish this sketch and start making the extrudes. So first I'll start with this particular extrude here, which is 12 mm. Select extrude, this section. So we have our shape ready here. Now the next point I will do is to make this cylindrical portion. The height above this surface of course is 12 mm as you can see in the drawing here. I can maybe even expand it for a second. So as you can see we made this triangular pad. Now we need to draw this cylindrical portion which will be uh, in such a way that with reference to this surface the height on the right side is 12 mm, and on the other side is 28.5 minus 12. So let's go back to the CAD and select this as our curve. Now here we need to, on one side we need it to be 12, and on the other side it is 28 point 28 minus 12. I'm putting it as it is just to avoid any mistakes. Let's hit enter. Okay, so there's already some issue here, so we need to change the direction of this. Okay, so this looks fine, and we can choose the boolean as unite so that it gets united to the previous shape. Now let's make all the holes. Let's start with the central one first. So we need to select specify a point. Let's select this. It will automatically take the center. Simple hole, we need a diameter of 40 mm. To that, and depth we can simply drag it so that or we can simply say through body. That should make it easier. And boolean of course is subtract. Let's apply. Now we also need to make additional hole with counter bore. Let's do that. Again we select hole. This time we need to select, we don't need a general, we can use of course a general hole with a counter bore. We need to specify a point, normal to face of course. The point of course is this and this. Now we need to specify the dimensions of the counter bore. So first we have the counter bore diameter, which in this case as you can see was 16.5 mm. Counter bore depth was 2 mm, and the hole diameter here was 11 mm. Let's preview it. Looks pretty fine, and let's hit OK. So as you can see, most of the drawing is already, or most of the CAD is already complete. The only thing we need to add is some chamfers. So let's do that. Here we can select the chamfer. So we have a symmetric chamfer of 1 mm here, and let's select both these edges and hit apply. Okay. So we already have all the dimensions covered. However, there are some features in this drawing which of course are not dimensioned. For example, let me expand this. So we can see that there is some radius here. So this is probably a resultant from the fact that this was probably a cast. This was initially cast into this particular shape, and these some of these surfaces, which are of course marked as machining required, are machined off. So these radiuses correspond to the casting radiuses. So let's randomly put some radiuses there, just so we can make the shape look as close to the drawing as possible. I'm just choosing a radius of 1 mm. Of course, there are specific rules with respect to what casting radiuses should be used, which of course depend on the size and the dimension of the part and the technology that we are particularly using. But for this, just for the sake of showing it, I am simply putting a radius of 1 mm everywhere. Let's hit OK, and let's hide the sketches and the datums. You can already see the part that we set out to create is already formed. Now let's also look at this section view just to confirm that the part that we made is exactly the same. In order to view the section view, we can go to the view. Here we need to click on this edit section. You can already see that we have a wrong view that has been selected. So let's try and select some other view, and this particular looks like the section that we actually need. Let's rotate this a little bit and try and orient it exactly as in the drawing. Let's hit OK here. You can see that the section that we actually wanted to make is exactly the same. The only thing is that the section that I'm looking at is the direction is reversed. So let's try and reverse that direction. Now you can already see that we are looking at the exact copy of what we set out to make. That was all for today's video. I would request you to stay tuned to this channel to watch more similar content, and if you have any specific suggestions or you want me to create a more complicated or a specific part that you are having difficult time with, you can drop me a comment in the comment section, and I will get back to you in a few days.